Hi everybody, welcome back. This is part 3 of least squares regression. That's our second to last new material, so we're almost there. What we're going to talk about today is two things that you can calculate from your least squares regression. So one is the standard deviation of your residuals, and then the second is that R squared that I talked about before. So let me go ahead and say up front, there are some, ugly looking formulas on this paper, neither of which you need to memorize. Your calculator will do all of this for you. So do not stress about that. And honestly, the standard deviation, you're not going to have to deal with much at all. It's just going to be, here's the standard deviation. Let's go ahead and interpret it. What does that mean? The R squared, you already know how to find it. When you do menu 414, it gives you R squared as part of your answers. So we're just going to kind of talk about what these mean, and then we'll move on, and then tomorrow we'll kind of wrap it all up. All right, so for looking at how the LSRL will actually fit all of your data, we would look at the typical prediction error, and that's what the standard deviation is. So this is how they find it. Basically, they find all of the residuals, they square each of them, they do a summation, so they add them all up, and then they divide it by the sample size minus 2, and then they take the square root of all of that. Yeah, that's ugly. You don't have to do that by hand. But just as an FYI, that's where that's coming from. All right, so back on the first part of these notes, we talked about a Ford F-150. And we were talking about the price and how it would decrease as the more miles were on it. So in this case, it says from the Ford F-150 data from earlier example, the standard deviation of the residuals, the lowercase s, was equal to $5,740. Interpret this value in context. And then they do kind of remind us that the explanatory variable, the x value, was miles driven, and the response variable was price. And so this one is a pretty set formula that you're going to follow when you write the sentence. So, hang on. So when using the LSRL to predict the price, of a Ford F-150 using the number of miles driven, our predictions will typically be off by about $5,740. All right, so when using the LSRL to predict the price, or to predict, that's going to be standard every time. Then you fill in your context, and then our predictions will typically be off by about. So this part and this part will be the same every time. The only thing that's going to change is the context and then what that actual standard deviation is going to be. And again, they're going to give that to you. That's not something that you're going to have to calculate by hand. This one is the coefficient of determination, there's a little bit more that you can do with this. It's taking the standard deviation that we just found. Basically, it's finding your residual and then squaring your residual. That's what we're dealing with there. That's what R squared is. And what it does is it lets us know how good a job the LSRL is doing at predicting rather than simply guessing. And so again, this would just be an interpretation. The higher your R squared, the better. The closer to 1 it is, the better. There isn't, the continuum would be from 0 to 1 as opposed to -1 to 1 like it is for the R's. So 0 would be not great. +1 would be really great. The higher it is, the better. So in this case, the way we could interpret this, it would be 66.4% of the variation in price of our Ford F-150 is accounted for by the linear model. Relating price to miles driven. All right, so normally we're dealing with out of 100%. So this is saying that 66.4% of the variation is due to the model. That means that 33.6% is due to something else. And in this case, for this car situation, what we could be talking about is variation based on miles, on the age of the car, on the color. Some people just don't like black trucks for some reason. They'd rather have a green one. We're not dealing with any of that. So the higher that percent, in this case it's 66.4, the closer it is to 100, the more dead on that model is, the smaller it is, the more variation it can be caused by outside factors. So this, the higher the percent, the better a fit, a better linear model it is. All right, pretty much that's it. We hit the big stuff with the last video with all the calculator steps. Like I said, tomorrow on part 4, we'll kind of wrap everything up. Thanks, guys. Have a good day. Bye.